after the introduction from Andy, we'll explore with you a data project, and you will see some examples of the job we do at Kensu. And if you have any question, feel free to ask them in the group chat, or raise your hand with the Zoom function there, and we will be happy to answer.
All right. Just wondering if I'm sharing on. Okay, that's fine. All right, thanks, Sammy. So really quickly about myself. So I am Andy Petrella. I am very happy to be here to talk about some methodology that we are applying at Kensu and why we created it. Well, about my experience, it started like, I'm almost shy saying it, but it started like 20 years ago. And I was working a lot with satellite and secret data back then. And you know, when you work with satellite and secret data, you really quickly learn about the importance of a rigorous methodology to first explain the models that you're deploying, like, you know, deploying a model in production, statistical model or learning model, whatever. So really being able to explain this, and also learn the importance of making the use of the data transparent. That's the first step, right? And then I dig into another period of my experience where I have been one of the pioneers of artificial intelligence in massive data, right? I was back then working a lot in genomics information, you know, genes and stuff, but also in IoT. And during this period, which is already 10 years old now, in the early 2010s, the tools were quite rudimentary, and that's why I created the Spark Notebook. The Spark Notebook was a very fun tool to work with, right? It was very early. It was used by more than 10,000 people around the globe, like data engineers, data scientists who were going back and forth with me, providing ideas about distributed computing and tooling for especially genomics and IoT. And actually, eventually, this tool has been used by many companies in the Silicon Valley, like Netflix, Amazon, and Apple. And that literally opened the doors for me to the Silicon Valley. And like it has been said before, I totally agree with this. It's important to participate to a community like the Polymoides, right? It's important also to be part of the open source and the open data and everything, because you expose yourself to different words, to different people, and it allows you to speak. And the Spark Notebook gave me this opportunity to work with this great company in the Silicon Valley, where I learned, you know, amongst these people who were managing like millions of data sets and thousands of models in production, that I learned there that there was one tool which was missing and one methodology which was missing, is about how to automate the collection and the management of data usage. And during this time, I created Kensu, of course, so that leads to there. And I very quickly become part of a fund over there in San Francisco, which is the Alchemist Accelerator, that allowed me really to propel myself. So by the way, I'm from Belgium, right? And I went to San Francisco really a lot of time to do that kind of things. And I'm very happy to be here to talk about this, the methodology, about Kensu. And if you wonder what the heck Kensu means, actually Ken means knowledge, and Su is for sustainability. It's really about how to make knowledge sustainability in your work, in your organization, in your enterprise, well, everywhere. And that's where we're gonna get started with, okay, we're here to talk about how to trace the data. Tracing the data is not only, I mean, there was a quick introduction to lineage. Lineage is really how data are connected to each other, right? It's like provenance, data flows, it has many definitions, but why should you trace your data? There are many reasons for that, right? So of course, there are risk reduction and cost reduction. When you trace your data, you know how the data has been produced, you know where the data comes from, you know if the data is still used, you know if the data is still has a high quality, or your model is still accurate enough to be used by the business, by any kind of organization that's still relevant. And when you have this knowledge, right, you know what you have to withdraw from your infrastructure, from your system, and when you have to maintain it or to replace it, right? And that's a huge cost that you are cutting, right? Because you are stabilizing infrastructure, you're not having data everywhere that are not used, but also you're reducing the risk of using a model which is not accurate anymore. Also, you can increase your income because if you know from where your data comes from and you know how your data is used and produced, then you know how you can operate it, and also you know how to reuse. I saw one part in the previous slides about reproducibility, right? Reproducibility is a lot, relying on the fact that you know where the data comes from and what it has been. What has been used in order to create it and so forth, right? Which is the lineage. And really, you can increase your income only because you have this information somewhere. The problem is how to get this information, right? And what if you don't trace your data then, right? Basically, tracing data really quickly becomes like, oh, damn, actually I have to write tedious documentation. I'm doing a model right now when I'm doing some data manipulations, and then I have to write once more everything. I mean, whether if it has to be done in Italian or English, but you have to write the documentation to explain how the data has been conceived and used and produced and learned from. And that's a huge major blocker if you think that way. The other aspect, if you don't trace your data and you don't monitor your data. When I talk about data, I'm including models, right? Because model is nothing but data for me. And actually what happens is that you start doing manual check-ins. Think about that, right? So I was working in genomics. I was mainly discovering diseases in genomes, right? Basically, when you deploy your model, which is learning and producing results for thousands of people, right? You better want to have your hands on and checking every day minimum, right? If the model is still kind of accurate, retraining it if you can and everything. The problem is that training one algorithm in genomics then take days, still with distributed computing, right? Because because let's say that it's a k-means and the k-means has 2 billion columns, right? So the data is not 2 billion rows, but 2 billion columns, right? Imagine the k-means, how long it would take. So that means that you're trying to do manual checks manually, right? Again, double checkings, it takes time and it's very frustrating. Afterwards, you can think about, yeah, tracing your data is like governance thing, is for managers. I don't give a heck about that, right? And again, it's gonna be hard afterwards to make sure that these governance rules are respected. And I hope you will do so because it's a fantastic word. Working with satellite images and some, kind of secret data, right? Actually, you're exposed to a lot of governance because you have to be ethical when you work with the data, right? And this is really what governance brings is data culture, right? You're having the right culture. And having the right culture is also being able to explain what you did with the data. Because if you can explain something, right, you don't understand it, right? It's a famous proverb, but it's really, really relevant in the context of data. So that's why you should trace your data. But what is tracing your data again? So tracing your data is really literally about when you're working with your Python code and whatever, right, or R or MATLAB or whatsoever, is always making sure that the information about what data is used and produces is maintained somewhere. But again, let's take an example. Let's take an example in the healthcare subject that I have been involved to, right? And it's really emotional to me in a way. So let's figure out. Let's take as an example the idea that the business and management side of the healthcare are the patients, the people who feel ill, right? And they are going to the doctors to ask, okay, what's going on? What should I do in order to get better, right? And actually, what do the doctors do is that they use diagnosis, questionnaire surveys in order to figure out or they detect symptoms visually, I would say, or manually in the patients in order to understand in which category they will land and what kind of disease they would have. The thing is, afterward, they use all the facts that have been told by the courses that they follow, of course, where they were students, also the experience, but also diagnoses that are coming from the pharmaceutical industry. Of course, they produce medicines and pills and drugs, so they provide also how we can detect the disease and where and when they should take the pills, right? The thing is that when they follow this even very precisely, you know, sometimes that can happen that people can still be ill after weeks of taking the medicine eventually properly. And this is really on the business side, right? It's like it's a world where the data have been used to produce a result, which is basically providing the pill to someone. And what happens if the people are still ill? The people, it happens, right? So I guess it's not new to you, right? Actually, the people becomes less confident. They becomes less confident into whom? Into the doctor, into the pill, into the pharmaceutical industry behind it and everything. That means that everybody loses confidence in something which has a very high value like the medical sector, the healthcare. The problem is that, of course, the doctor doesn't know how to react to that because he doesn't have the right data. So what do? They come back to the pharmaceutical team and say, guys, actually I'm following all the right rules and the people are still ill. What should I do? I'm very hungry here. The people are going away from me because I cannot heal them. Right, actually what happens is that it comes to the data teams into these industries. These people who were managing the population, that these people are generally, you know, biostatistician, right? And these people are massaging as much information as they could, but they don't have plenty because it's very expensive to run medical tests and clinical tests. But what they miss the most is not the population. What they miss the most is the information that comes from directly from the patient that were taking the pill, right? This information which is in production, where the medicine is used, this is the information they miss. And you know what? In order to get this information, they have to go through again the management, which is the doctor, asking, okay, I know you're hungry. You know, I know that everything is actually going nuts here, but can you please go back to your patient and ask them if they were taking the pill seriously or they were taking the right pill or whatever. And actually, this is where it creates a lot of frustration for you guys when you're doing data every day, data science, statistics models, and everything. And that's the bare reality of everything in the industry. So what do? We say, okay, I don't have information on this side, so I try to create it. So I will ask from population in order to test further. I will try to create more variables in my data in order to see if there are clusters that I missed. Also, I will try to see if there is anything missing in the IT system. Did I use the right data? Did I use the right population? Is there something that went nuts when they were producing the data that I was using in order to do the classification and stuff? And this can take, I'm not lying, months, years sometimes. And at that time, people are still ill, you know, right? And it takes so much time because you have no information about where the data was coming from, the quality of the data that you were using, and you don't know what is going on in production, mainly in the wild world. And in this specific case that I'm taking here, the problem was that during the clinical test, they forgot for one reason or whatever, right? Because you cannot have millions of people testing, right? They didn't have enough population for young women living in cities. You know, it's like a sub segment. And you know what? There are many women living in cities, right? And many people can have this disease. And the fact is that this population was missing. And the diagnosis, then you probably understand that very well, right? The diagnosis was including this category into their surveys. So that means that the accuracy of the diagnosis is very bad. And of course, the doctor says, okay, you fall into this category, then you should take this pill in a way. But the thing is that this subcategory is not reacting to that pill. It's another disease, right? And that leads to what? Nowadays, when you talk to medicines, physicists, and everything, you talk, okay, do you think that at some point there will be errors when you will diagnose a disease? 86% of the people, these medical people, right? So they are part of the medical sector. They will say yes, there will be an error because they are not confident anymore in how to detect and what they use from the pharmaceutical company. That's a failure. Basically, that's a failure because there is something missing out there. And this example is here in order to explain, the methodology that today we're introducing more and more with something that I recommend you to check in the internet about data observability, which is basically what we're gonna talk about today. And observability is something interesting because when you think about the data science project, it's always, yeah, I will look for something to do with the data, right? So maybe it's gonna be, predicting disease for the COVID, let's say. It's very popular nowadays, or predicting something that should happen in the coming days somewhere in the US. I don't know what I'm talking about, but maybe trying to predict that thing. And actually you search, okay, it's an opportunity. I can create a blog, or I can expose this to my managers. They will be happy. So let's do something like that. Then what you will do next is explore the data that you may find and use. And afterwards you create your model, and then you want to deploy in production, let's say, in order to have it running in the real life. The thing is that when you want to monitor yourself, you will think, okay, I'm going to track everything I'm doing, basically collecting the metrics of my experimentations. So what are the accuracy metrics that qualify my product, let's say a model or a report, let's say. The thing is that you only place one visual, one probe, let's say one metric on one step of a huge pipeline of data transformation, right? You give yourself a limited context of information, right? So that means that you only know if the model seems to be fine, right? But you don't know if it goes wrong, where the problem may come from, which is basically you cannot perform the root cause analysis, right? Which is the thing that takes you months to discover, right? And that's the idea that we're introduced today. And Sammy will go through in more details about, sorry, how you can do this, today with your code, right? Basically, or your tools. So the idea is that in order to allow you to do root cause analysis, basically, oh, my prediction model, is going nuts today, and I know that it comes from this data that is coming from this part of the IT, which is producing information that has nils in there or NAs in there, right? In order to do so, you need to have not only an eye on your step, but you need to have something which is looking globally in order to have the contextual usage of your data along the pipeline. And that's why here I'm showing a very simplistic, of course, data pipeline, which is taking data from files or database and extracting data, cleaning it. Of course, here we are taking the whole data and we're sampling it. Then we join the data. Then we are creating the data mart, which is basically huge metrics that you can use to classify and then learn from different categories, right? Then you put your brain on basically your model, and then you can create some prediction and reports. Actually, by having an eye on different steps, right, the dependencies, right? I'm talking to a bunch of very smart people here. Think like this pipeline is like a Bayesian network or a deep belief network, right? Basically, everything that has a issue somewhere can have a big issue elsewhere, right? And then you want to discover which one has the highest probability of creating this problem later on in the process. Actually, the problem is that you don't have this everywhere, right? You don't have this all the time. So at least what you want to prevent yourself from being in a bad situation where someone comes to you, say, you don't know if you have to check your model. You don't know if you have to check the incoming data. You don't know if you have to check the in the IT if the data that we're ingesting or collecting from third parties or from the web or whatever were wrong. You are clueless, which is the worst situation that you want to be in. That's why by introducing the methodology that we'll explain in the next part, you can do root cause analysis efficiently because you have the knowledge about how the data has been processed. Now, what we're talking about here is really about managing data intelligence. You may have learned about this during your courses, but you'll surely learn about this later on. You will be out there in the industry because data management is today very something important because data is so important, right? But the thing is that a lot of people forgot that data is useless if you don't use it, right? That means that what is very important for managing, to manage in your daily work is the intelligence that you put on the data, right? Basically the applications, the models, the transformation, everything. And this is something that you need to manage. What you need to manage is monitor it, basically looking at different facts, statistics, metrics, accuracy, and everything. And when something goes wrong, being alerted, this is monitoring. Lineage, in order to do the root cause analysis that I've talked about, in order to not be clueless when someone asks you something. The quality is embedded into your work, into your experimentation. So you know what is the quality of your data that you're using, and you know what is the quality of what you produce. And observability is this thing that is also including the schema and everything. And this is what data intelligence management is outside of the data itself. I hope that was pretty clear, because now we're gonna dig into more, hands-on thing, why and how should I do this, in my daily work, and how can I even do this during my thesis or my work with for my professors. Think about this, right? So what we're going to introduce is you do your work with your code, and the end of your experimentation, when you have your model created that you like with the highest accuracy, then you have something that has been collecting everything that Sammy will demonstrate, that can show to your professor all the different steps that you have performed, which data you have used, which transformation you have created, which intermediate data set you have created, like featureization and everything, what kind of models you have tried, which hyperparameters you have been using, and what are the models that you, at the end of the game you have picked. Everything is in the code, everything is in the monitoring that I was talking about, and that will be introduced by Sammy. Sammy, floor is yours.
Okay, so I will share the screen. I'm not able to share the screen. It seems I have to be, okay, now it's possible. Thank you. Okay, so thank you, Andy. So now you just have a quick introduction to the data intelligence philosophy, and we will now put our hands in a real life example to understand how data intelligence and data observability can be used and why it is important. So let me explain to you the context of the project. So let's imagine that we are a data team and we are working on a so-called data product. And the product is a loan acceptance program, which will be used by bank agencies. So when a customer who wants to have a real estate loan comes to the counter, an employee would fill in some personal information, such as his income or the marital status. And then the software will tell if the loan is accepted or not. And so the model is based on the probability of default of the customer. So we will have a more detailed look at the structure of the project. And well, thanks to a data intelligence manager, you can have this kind of representation. Here you can see the whole life cycle of the product. so of the project. So from the data collection to the model backtest. So in this view, each card represents a notebook, and each link is a data flow, so a data transfer from a notebook to another. If I filter, for instance, on the lab part, so on the training part, it represents the processes done by the data science team in order to prepare the data and to train the model. And so here we can see that we have 3 processes. So the data preparation, so it's where the data sets are, well, they are prepared, so extracted from the master data, and we do some modification. Then we have the data mart, where the resulting data set, so we use the result here to create a goal matrix that will be used in the analytics part. And so in the analytics part, hello,
Hello?
hello. Okay.
Yeah, there was some trouble.
So I was talking about the production part. So in the production part, we will have the data prepared, then we will predict. So we will use the model to predict if the loan is accepted or not. And sometimes we will also backtest the model, so to confront the model to the reality to see if the performance and the accuracy is still okay. So in fact, in here inside each notebook, you can see what happened in the notebook. So if I take the lab phase of the notebook, we can see here the data sources that were used in the notebook and the lineage. So the data flows from the input data sources to the output data source. So let's see how data intelligence principles can help you in your day-to-day work with some use cases. So we'll explore here 5 pains that data scientists may face and how the tracing of data can help you to avoid this. So first, and as you will certainly experiencing, a big part of the job of the data team, it will rely on data cleaning, preparation, and featureization. And so you will often have to clean data sets to be consistent with your model or to make them what we call so tidy, to have a tidy data. And of course, you will need to justify why you made some choices instead of others. And with data intelligence, it can help you as it keeps records of all the data transformation you perform. And let's take this simple example. So here I have a notebook. So I'm inside a notebook of data preparation. So sorry, can you still hear me? Oh. Okay, so you hear me. So I was saying here we are in the first notebook, so the notebook of the data preparation. And as you can see, I'm reading, so it's a PySpark notebook. I'm reading 4 data sources, and I'm joining them, and I save it in the data org .csv file. So this is what you can find. So what you can find here. So I have those data sources, and I'm creating the data org file. But then, as you can see, I am also cleaning the data. So I'm filling the NA values. And well, we have to be sure that the new values that I filled won't interfere in the general quality of my data. And so we can check in the data intelligence manager what was the impact of the transformation on the data. So if I look at the data org data set, we can also compute metrics so that we send with the lineage. And it allows us to understand the modification of the data and what it did to the data. So for instance, if I take the loan amount term field, I see that I had at the beginning 18 missing values, and I decided to fill them. I think I filled them with the mean, and with the data intelligence manager, so I'm keeping track of all the, the transformation, and I can also see that well, the transformation has no impact on, for instance, the median or the mean of the data. So thanks to the data intelligence manager, I can be sure about the quality of the data. So next, let's imagine that now, so the data are prepared. We are training some models, and we need to decide which model should be shipped to the production team. So you will have to define what the best model is. And a good model is a model which is so first understandable and also accurate. So to be sure that the model is good, we have to understand which data is used in the model. And to do so, we can use another pillar of data intelligence, which is the data lineage. So all along the creation of the model, the data team has logged which data were used. And for instance, here, sorry, here you can find the data that were used by the project. So if I take, for instance, this data source, I can see the data and the processes. So the processes that use my data source, which is called profile. And I can also choose one process. For instance, I will take the analytic process. So this is where I trained several models. So I trained 3 models. So one decision tree here, another here, and a random forest model. And as you can see here, I have a red lineage. And the lineage is red because, in fact, I'm using private and personal information. So let's see which field is used. So if I go to this model, well, it seems that in the decision tree, I'm using the gender to decide the allocation of the loan. And this model will likely be rejected by the management. And this for ethical reasons, because nobody wants to discriminate to grant a loan based on the gender. So thanks to the lineage, you are able to understand the building of your model and to know that this model should not be used and shipped to production. But then, as you can see, we still have two models. Sorry, we still have 2 models in the notebook, and we have to choose one to ship to the production team. So here we have 2 candidates. So the decision tree and the random forest. But in reality, in a data team, you may have a lot of trained models with different hyperparameters, and moreover, several team members may try different models on their own. So you need to centralize this, and team often do this in an Excel sheet, and of course there is a risk because you may forget to register a model, or you may report the wrong metrics. And by using data intelligence practice, you can centralize all the trained models and evaluate the performance. And so, for instance, for this project, we can centralize this. So we have the model leaderboard when we can choose the best model. And for instance, here I will take this one because I will look at the area under the rock, and I will take this one to be shipped in production. So thanks to the data intelligence, you can also have a tool to easily compare your models. And so now that you have a model, you will ship it to the production team. So now you have the control on the data that were used because you choose a right model using data that you were allowed to use. Then you choose the best model with the best accuracy, and here in that case, as it is a classification, the best area under the rock, for instance. And now you're sending the model to production. But the production team will run your model periodically. So they will report this in a prediction table. But at this stage, and that's often the case, the data science team is blind regarding the performance of the model. But hopefully, if you apply data lineage and monitoring, well, you can log interesting information to be able to prevent and to detect any production incidents. So you are able to give a ticket about an event. So let's look at this. So because you had logged statistics, you were able to be notified about an event, and you can quickly notice it. So here, for instance, we have a strange behavior in our model. Well, the business rule is to grant about 70% of the loans. So, and we see that the threshold has been hit 3 times so this year. And we will check in the table. So as you can see, we granted more than 80% of the loans in October, November, and December, compared to 70% the rest of the year. So now we have detected the incident, so you can be more confident about the model which is put in production. But now that you were alerted about the incident, you need to understand the impact and to find so the impact of the incident, and to find clues to identify the issue. So first, let's check the impact. So to analyze this, you can see if the prediction outputs were accurate. So, sorry, here you have a backtest model, which tells you if the model was accurate. Because as I said, so we granted more loans in October, November, and December. But if people are able to reimburse them, it's totally fine. But we need to understand the impact. So we will look at the metrics that we reported in the backtesting model. And we will look at the same months. And as you can see, well, the precision of the model is lagging behind. So compared to the other months, it's usually 90%. Now it's 80%. So it means that people were considered as solvable, so as credit worthy, but they were not able to pay back the loan. So this may have terrific consequences. So let's imagine that the total loans it is worth something like 2 million euro. You are losing 200,000 euro because of misclassified people. And moreover, you can also see here, thanks to the specificity, that well, you have an issue when you are trying to identify the the bad payers. So to understand why we have this issue and why the model fails here, well, you can use the lineage to write up the data flow. So I'll come back here. So the model is located in the predict notebook. And you know that in production, the predict notebook use data from the data mart, and it's coming from the master data in the data prep. So we will check the statistics of the input data sources coming from the data mart. And as you can see here, so we have a drop in October, November, and December again. And the drop, well, it is due to the applicant income and the co-applicant incomes. So I will specify to check the last 3 months. As you can see, so at first it was expressed in units. Now it's expressed in thousands of euro, for instance. And so you see that there is an issue here with data. Thanks to the lineage, you can understand if it's an issue in the process or in the original data. So for instance, here, if I write up the data flow, I can come back to the origin of the data. So even before the data org, I come back here. So in the PySpark data prep notebook, I know that data org is coming from personal info, income info, and credits. Here I was talking about the income, so I will check here. And as you can see, you have the same drop. So it means that now you are receiving your data in another format. So you have to fix your model and your data pipeline according to this. And so this is what we call the root cause analysis. So it's to analyze the cause of any issue that may happen in your data pipeline and which has an impact on your model in production. So and finally, so all of this was possible because you incorporated logs and logging at each step of your data pipeline. So in each notebook, we decided to put logs that will be sent somewhere. So you may produce log files, or you can send this to a server or to a tool, so a dedicated tool like we do at Kensu. But the goal is to log all the data transformation that you are doing in the notebook. So the transformation, the statistics, performance metrics, the code version, and so on. And those information may be very interesting when you are facing an issue, and it will help you to debug and to understand the failure in minutes or hours when it can take days to find the root cause. So do you have any question on this case? I will try to find the chat. It's here. Okay. see the. Okay. Well, so if it's okay, I'll move on. So yes, here you have the well, to sum up what I said, here you can see why data intelligence is important and how we can help you to in your day-to-day work. So, for instance, well, if you are working in a company, you will often have to register all the data sources that you have created, often in the data catalog. And so it means that once the notebook is done, once you have created the data source, you need to take the time to go in the data catalog and to register manually the data source, which may be problematic because sometimes, well, you're not writing the right data source, the right location, can have mistakes. And so here, with logging inside the data, inside the notebook, you can automatically collect this information. So it's true for the data sources that you have to log, but also for the models, the processes, and as you saw, the metrics when you are running a models, and it will allow you to choose the best one at the end when the whole data team come together and they try to find the best model. Moreover, so what we do, so what we advise to do is to compute the data quality, so the statistics in the notebook and not outside the notebook. So for instance, now you may have tools that will take all the data sources in a SQL server and compute metrics on it, but the data quality outside the context doesn't make sense. So as you saw when I was trying to debug the production issue, I had to look at the data in the context. So with the data lineage to understand which data were consumed by my process. And moreover, it takes, but yeah, this is another story, but it takes less resource to compute the statistics inside the notebook than after in another process. And yes, so and finally, well, you can be confident, and this solves the issue raised by Andy at the beginning of the presentation with the vaccine use case. You know, data scientists can be confident in the robustness of the models, and they will be notified, and they will introduce monitoring in the data. Well, to be proactive in case of issues. So I'm at the end of my slide. So I will let the floor to Andy, who will sum up the advantages of the data intelligence. So thank you, everyone.
Well, okay. Let me maybe share my screen one more time. Sorry, I was enjoying discussion during on the chat. So, Sammy, if you want, you can jump on that discussion. That's very interesting. All right, okay. Let me try to put my. Where are you? Over there. Can you still see my screen? I'll take a silence for yes.
Yes.
Okay. Which is probably the worst thing to do. So these are all the great stuff that Sammy demonstrated. So before I get started, maybe I don't know if there is anybody that wants to ask a quick question before I jump into the last part regarding what Sammy's demonstrated, or don't be shy. Yeah? If there is any question, of course there is a chat if you're a little bit shy. But wait a second. I know this will never work, right? So every time I try to do this, no one tries to talk. It's a classic. Anyways, all right, okay. So what we've seen here is really that the methodology that we're pushing, on the foreground, and this is something that really picks up in the US, for instance. It's very interesting, by the way, just making parentheses here, because I believe that I should share it. It's funny, but if you go, if you have the chance, oh shit, with the COVID, it's gonna be doable. But anyways, if you have the chance to go a little bit in the Silicon Valley or the cities like Seattle or Boston or these kind of cities where data companies are exploding and they are very, data is native over there, right? So depending in which community you will land into. But the thing is that in a way it's funny because when you go there, it's like going in the future, right? Because they are always like a few years ahead. So it's like going in the future, you see so where they are today and everything. And I hope that at least one good consequence of the COVID will be that this kind of native thinking about data value as an asset and everything will also reach through Europe. I know it's already out there in Asia, so it has to reach also Europe and increase our maturity. And I hope that it will go through the pipes of Zoom's meetings and the Teams meeting whatsoever. But it's still interesting to go there. So if you have the chance to do so, I mean, don't hesitate a second, right? So basically what we're talking about here is to provide the applications, the power to manage and monitor their own data, right? Manage and qualify and monitor what they are producing, what they are doing, right? So rather than trying to qualify the data outside of the context, right? Trying to qualify it within the context, right? The context here, again, is the application. What is the application? It's just the transposition of your intelligence into a piece of code, right? That's nothing but just that, right? There is yet nothing that can generate, algorithm whatsoever. You can think about things like data robots, AutoML or whatsoever, but I can tell none of these things will be used in production because you cannot explain what's going on out there, right? And again, never use what you cannot explain. Never do that, right? It's a matter of life and death, right? So it's basically as big as this, right? So trying to pop the chat on, but it doesn't look like I can. Anyways, so here again, the idea is to provide this power to the applications, this power to you, right? So that you can manage and understand what it's still doing. Well, I've been in situations where this could have saved my ass so many times, right? When I was using satellite images with many cloud, satellite images, I really recommend also trying to get into this kind of data because this is fantastic. This is terabyte of data, 13 layers of information, different bands, different frequencies and stuff. But you can have a small cloud, screwing your own algorithm. A cloud, of course, is something that happens. We're in Belgium here; it happens every now and then. But I mean, a cloud can screw the whole project that you have put right, and this could have saved my asses so often because only me can understand the impact of a cloud in a special area where I was providing insight about where troops should be deployed in order to provide the best humanitarian help for the people, right? So again, So provide this power to your application, provide this power to you, right? And this power is really about many things, like has been explained by Sammy. First is, of course, putting yourself in a situation where you can find the cause of a issue, right, in an efficient fashion, right? So you're not clueless. You can answer. You know where the data comes from. You know what is the quality. You know what will fail it, right? You know what had failed your process. You know what had failed your models, right? You have the history of everything, right? It's somewhere. So you're not clueless. It doesn't mean that everything is instant, everything is rapid, everything is fast, but at least you have the information. You're not clueless, right? That's very important. I know that I'm repeating myself often, but it's so important that this has to be evangelized, and it happens out there where I was just talking about in the US and Asia, but here it really has to be told more and more and more. So provide yourself arms and weapons, to answer tedious and hard questions. So here, for instance, you see that you may have a problem in some projects, you have information that there is an alert that comes to you, say, there is a problem with the models, it's not going well, so the robustness is nuts, so the accuracy, let's say whatever index is going cuckoo, so we need to get something out of this. You know that you're using the new customers, which are age of at least 50 years old, right? You know that you're using this data, you have some information about that, you know this information came from the master data on the customer, master data in the customer, the customer master data into the data warehouse, and except and so on and so forth, until even the Google form where information about your customers were entered, right? But at least you do have some information that will put you in the right shoes. And that's crucial, because I hope that when you start working, and if you're already working, right, you want and you will produce models, very, very friendly, right? Because it's important to produce fluently, because you need to put them in production. You have to confront with the reality early as possible, right? That means that you do something, you experiment in, it works, boom. It doesn't have to be full perfect. You need to experiment it. May that be with A/B testing or whatsoever, but please do experimentation in real life, right? And then when this is experimenting, don't waste your time and looking at it like a monkey for hours, right? Work on something that you can still produce, right? But do something in a way that you will be notified if something goes wrong, so you know that you have to put some maintenance on, some improvement on the project, right? That means that if you're producing, like, I don't know, 2 or 3 models a month, right? It may be big, but let's say 1 model a month, right? At some point in time, you don't have enough time anymore to look back at all the models that you have created along the year, right? So you don't have time in one day to control all of them, right? That's why if you want to have fun when you work with data, if you want to enjoy producing high results, right, you have to deliver fast, but you have also to monitor what's going on. I hope it does make sense. And I hope it had made sense for many people years ago when data science was almost, 1 or 2 guys, like teams like I was part of, I hope that we had thought about this before. And so today we would have all the tools in hands to avoid this kind of situation we had been. But yeah, the story, what it is, but now we have tools and we have maturity to include that into our processes and guidelines. One more thing, I was just asking this question in the chat, before jumping on the floor. So why do you have to write, documentation manually, right? I mean, it's nuts, right? So we are like working with data. The idea is to automate learning, right? So basically, when you're working with data and using machine learning, you want to automate the learning, right? And what do? Is that the code that we produce, we manually, humanly, inaccurately create the documentation that is linked to this automation. That is absurd, right? This is absurd because, of course, it's not pleasant, it's not funny, and it's like repeating yourself in a less structured fashion, because full text, I mean, for people that are doing NLP out there, we know that full text is not very well structured, right? So there are many structures. It's not as well structured as can be Python code or other type of languages. So basically, create, with this amount of information that you're collecting on your own work, meta information, right? So it's really about meta information out there. So collect everything so that afterwards you will be able to generate some part of the documentation that is requested in order to, put you in a very confident fashion, right? And also in a less anxious situation too, right? Here, so we go from code, from structured information about the lineage, about the quality and everything, and then we can produce a bloody, awful, black on white documentation, and that's enough, right? Another advantage is, of course, as I said really early, is about governance. Governance, you can think about ministers and kings and kingdoms and knights and whatever, right? So governance is really about, making sure that what is going on in following certain principles, certain standards, and matching some policies, right? It's important when you deal with data, because as shown Sammy, so sometimes you use data without even being aware of, right? Let's say you plug into a database, you fetch all the data, you put it into a deep learning, no, not deep learning, it's gonna fly, but into a random forest, for instance, right? So you don't have to provide a specific matrix to it. You put it into the random forest and you produce a result. Oh, fine, it's gonna be great. But when you do the query into your table, you gather new information you were not aware of, right? Oh, yeah, the business asks to add a biometric information in the table. Okay, you didn't had any notification about it, right? You include it into your process, and then at the end of the game, you're predicting car insurance failure based off biometric information. That's totally unethical, right? So you cannot do this. It's gonna be perfect, right? So you will have a very good model, but think about yourself when using the data. Do you want to be exposed to such results, right? Think about yourself. Never do to anybody else that you don't want to sustain yourself, right? So again, governance is really about that. It's about data culture, right? Nowadays, when we heard about the data governance whatsoever, governance, like, oh, this is for the audit, this is for the managers, I don't care, right? So I just produce whatever small documentation they need, and I don't care afterwards. But then you expose yourself to unethical use by mistake, right? And I've been there, right? So I can tell. By full mistake, you can include data that you feel totally how to say, shamed of, especially because you cannot explain how this data has been used, right? So the governance, who is responsible of the data, process and everything, this is really something that can be automated with the right, structure in the company. And this cannot be something manual. That's not possible anymore. And this leads to this compliance fact, where you need to be always aware of what kind of information that you're using in your projects, in your models, right? And then you can mitigate, right? Well, look, okay, I'm working in the retail, right? And look, we are using data that comes from Facebook and everything, right? But I can tell that we have two models, and you tell this to your business, right? I have two models. I have this model is really, really well made, is very accurate, but yeah, it uses personal information that you might not be happy with, because we're using, let's say, correlation with purchases that they have done in another company. Let's say we are Carrefour and we are learning from data about customers that who bought in goods at, I don't know, what do we have in Italy? I don't know, something as in Carrefour. And actually it's not compliant in a way, right? So because you may not, you have to explain this, right? You have to note everything and you have to create documentation about this, but you need to explain it. And then there is the other model that shows, look, actually this model doesn't use this. It's a little bit less robust. It's a little bit less accurate, but at least it doesn't use it, right? So which risk do we take? How do we mitigate? How do we cut the choice? Do we go with the kind of an ethical, like a borderline model, and we will be exposed to Colruyt or whatever other retail that may attack us and pursue and sue us, or do we go with the less accurate? We do less money, but we are also peaceful, right? That's the kind of information that the people will expect from you and from us, basically. If you cannot tell that, boom, you're gonna be exposed to, well, these guys don't really know what they do. Shall I be confident into them? Like the doctors that I was talking about. As a wrap up, to finish up on that thing, what was preventing us to do so, and what were the causes of using data without tracking your own work, right? So we were talking about data documentation. I mean, you can generate most of it nowadays. I mean, with the information we can collect from code, geez, I mean, this is very easy. Manual quality double check, let's say going to the model and the production, trying to see if the statistics and metrics are all good. Well, no, you don't have to do this anymore. You can focus on the high value they can generate in new models by monitoring what you had done in the past, right? Automatically. Cumbersome control of governance guidelines, right? Instead of always thinking about all the rules that you have to respect when you do something, right? You rely on some systems that can use these a kind of rule engine, even simpler rule engine, in order to notify you when something is done in an appropriate manner, right? So that means that you are more relaxed when you're doing your work. These are the different, outcome of monitoring and tracing your data analytics and everything. And that's really a methodology, right? So as I said, so you can check out with data observability or data intelligence management. This is really about how to bring the data governance and everything that was happening in IT to the analytics and artificial intelligence world. And how should you trace your data? Sammy demonstrated part of it. Of course, there are models, collators, and everything. You have your data, you put into your code the power, you provide the application the power to monitor that. We generate this code is gonna generate a trace with a repository that does the graph matching and all the learning necessary in order to align everything. You monitor, that means that you are notifying when something goes wrong. You validate, that means that you can track, the history and see what is the correlation between two events into your history in order to generate reports, as I said, documentation and such, reports for the business, reports for the compliance, and everything. And that's really to soften your burden, if I may. And that's really what I wanted. We wanted to share with you the methodology and the paradigm that we are pushing on the foreground of the data science community nowadays in Kensu. Actually, when we will follow up with this document, there will be one or two links. At least this link, where it's a kind of funny tool where you can check on your data management maturity. So there are a few questions, and at the end of the questionnaire, we will tell you what kind of famous movie character you look like. I'm not going to name the movie character that we have picked to describe the maturity in data management. There are 3 of them. The text is kind of funny also, so I recommend you to go check it out. So it's the URL is over there, but we will provide it. I guess Kaya will do the follow-up with the materials. And a few last words. It's 56. I try to go fast. A few references that I highly recommend, right? At least 2 of them. So look, there is this one here, right? Which is written by Google, basically. It's hidden technical depth in machine learning systems. I mean, it's like, I don't remember, it's 15 pages, something like this. It's very short, very easily to process, right? And it has been done at NISPs, right? So a neural information processing system. And it dates from 2015 by D. Scully. This guy is awesome. And this book, this little report is explaining, many concepts that we have also introduced today with a different perspective, but still very interesting article to read. There is another article that it's a little bit longer. I mean, sometimes a little bit boring too, because it comes from the European Commission and there is a lot of jabba haba over there. There's some very dense text, but if you read it in diagonal, right, even the diagonal, you look at the different concepts that introduce, I recommend these guidelines for trustworthy AI that has been delivered by the European Commission. It's very interesting, I must say, that you can see that they have asked to the right people about the right thing. Of course, these are only a few references, but we'll be happy to share some more if you stay in contact with us. There are a few books that I have in mind that I would highly recommend, like the dark data and why you should matter what you don't know, for instance. That's an awesome book. I should have put the links out there. We'll do it the next time, but please don't hesitate to reach to us. I heard that there is an opportunity to post jobs into your new portal. We'll have to discuss about that with your community, and I hope that we will hear back from you. And I hope also that you have liked the demonstration and the methodology today.